Hey everyone, today we are going to discuss managing soil fertility because I know for myself, at least for many years, I found the idea of fertility management, what to add to the soil, when and who to ask, all very daunting. However, I have tried a lot of stuff over the years, spoken with many people, read numerous research papers, consumed a fair amount of beer, and have ultimately come to some reasonable conclusions about how to manage soil health. It may not be what you think. We will talk about some essential things to do for soil health, and at the end, I will give you my general approach to managing soil on the farm. Let's get into it. I truly believe the beer was essential. Is that not science? First things first, if you are not subscribed to this channel, make sure to hit the subscribe button. If you gain something from this video or any of our videos, you can always support our work, which allows us to keep making content like this. Now, I am hardly the final word in fertility and soil management. I am not a trained agronomist or a soil ecologist. I am just a nerdy grower who likes to dig into research and has tried a ton of things on our farm, but who has also notably only ever farmed in one specific region on those specific soils. In that way, I suggest you add any insights you have learned from your own regions, contexts, experiences, and education to this conversation in the comments section as we go along. I am going to lightly touch on things like Korean natural farming, JADAM, and those sorts of practices. I will also briefly discuss nutrient balancing and so on, but what I really want to focus on with this video are the 4 or 5 things that, if you do not do them, nothing else you add to your soil will have much effect at all. The thing that does not get talked about enough regarding amending soil is that we often see deficiencies in our plants, or diseases, or pests, not necessarily because a nutrient is lacking in the soil per se. It can be, but often it is because the soil is physically not in a good enough place to offer that nutrient to the plant. No amount of, say, biodynamic preparations will save poorly draining soils, for instance. You can balance your soils all day long with the perfect collection of rock minerals, but without good moisture, you have just got expensive dust. The flip side is that if you do these few things I am about to discuss for your soil, you may find you really do not need to amend much at all, saving you time, money, and confusion. The first thing you really need to address to make any amendment you plan to add to your soil effective is soil compaction. Soil compaction, essentially the smashing together of soil particles, can greatly reduce root penetration. It can cause anaerobic pockets that produce gases toxic to plant roots. It can be favorable to pathogenic microbes. Compaction can hinder gas exchange, so plants and microbes alike cannot breathe. And that is just a small sampling of how compaction can make things difficult for your production. Chances are, if you have dense soil at all, meaning a higher percentage of clay, especially if it has ever been plowed or tilled, driven on, or had large concentrations of animals, or even if it has only ever been a tightly mowed yard, you likely have compacted soils. But let's not guess if it is compacted, because it is relatively easy to figure out. Determining soil compaction can be done with an expensive tool called a penetrometer, but I want to be clear that I believe you can get equally reliable results using a 4-foot piece of rebar. I am serious. Pushing a penetrometer into the soil tells me very little that pushing a piece of rebar into the soil doesn't, except that the penetrometer is perhaps a little more exact and very expensive. So don't buy one. See if an extension agent will lend you one, or just use the rebar. Either way, to test compaction, push one of these 2 instruments into the soil you intend to plant when the soil is not fully saturated. You do not want to do this right after a rainfall, but you also do not want to test when the soil is fully dry. Reasonably moist soil will give you the best idea of your compaction. Push the tool into the soil, and when it stops, that is where your compaction zone or your hard pan is. It could be just below the surface or several inches down. On our scale, we can address this sort of compaction by broad forking. Basically, this is a tool with several tines. It is very large and heavy, and you shove it into the ground, pull it back, and just lightly pop the soil. You do that for a couple of years, and the compaction generally goes away as long as you are doing it in conjunction with everything else we are about to discuss. It is sufficient for breaking through compaction, On larger scales, the version of this tool is a subsoiler. Perhaps. Just do not do it when the soil is too wet or too dry. Working the soil when it is too wet is an especially great way to cause further compaction. A simple test is that the soil should lightly crumble in your fingers. If it slicks at all, it is too wet. I know there is a lot of buzz about decompacting soil with biology and cover crops. I am not going to say those do not work because they certainly can over time, but they need help. Instead, I am going to recommend you use things like compost slurries and cover crops in conjunction with physical decompaction, such as broad forking. That greatly speeds up the process and makes the effort of adding a biological amendment, like a good inoculating compost, or going through the trouble of growing a good cover crop more effective. Plant roots, which can help open up the soil and keep it apart, will do that when they have those holes from the decompaction to get into. That is a nice segue into talking about the second thing you must do to make your amendments effective: photosynthesize. Well, not you exactly. You cannot really do that except in the creation of vitamin D, where humans and other animals literally use sunlight to create vitamin D from a type of cholesterol in your body that we then use to metabolize calcium. Because when we evolved from being sea-dwelling creatures to land-dwelling, calcium was much harder to find. So we animals developed vitamin D from sunlight. So I guess you do sort of photosynthesize. Man, that is cool. But that is not going to help you with making your amendments more effective in your soil. For that, you need plants. You need a diversity of plants. It does not have to be living pathways and interplanting, just a good rotation of multiple crop families. You need some amount of plants to be in your soil year-round where possible, and you need to leave the roots in the ground if at all possible after the crop is terminated so that the microbes can feed on them. What are plants doing that is so important to making amendments available? Well, plants provide the energy to the system by converting sunlight, water, and carbon dioxide along with various nutrients, a process we call photosynthesis, into glucose, which is just a carbohydrate or a little molecular bundle of energy. But that is a lot of jargon. Think of what plants create through photosynthesis like sweet little biscuits that they send out through their roots in exchange for nutrients from microbes. Microbes consume those biscuits because, well, they are delicious, and that gives the microbes the energy they need to live, but also to engage in decomposing amendments for plants. We know how this works, right? Microbes spit an enzyme onto a rock mineral, or some organic matter, or a flake of alfalfa meal, or whatever it is. It is kind of like spitting, and that rock mineral releases a bit of the nutrient. The microbe then absorbs that nutrient, so when the microbe dies, said nutrient, be it phosphorus or molybdenum or whatever it is released into the soil in a plant-available form, a form the plant can utilize. This isn't the only way plants get nutrients, but all ways require photosynthesis. And so, if you are using non-synthetic amendments like rock powders, but even things like blood meal or composted chicken manure or what have you, you need a lot of energy in the system and a lot of microbes in the system just being the soil, to convert those ingredients into something plants can use. Cover crops are one option for increasing that energy, but also just growing anything, even cash crops or even weeds, is better than nothing, though I, of course, do not intentionally grow weeds if I can help it. But the point simply being that plants feed the soil, and like I will say a million times in my life, if the soil is not being fed, it is feeding on itself. This is probably not going to come as much of a surprise to you, but you kind of need water. You personally need it, plants need it, and every organism on Earth needs it. It is a requisite for life and for photosynthesis. Microbes need water to move around and give them the enzymatic spit that they require. But also, if you want to get a nutrient that you've added to the soil inside of your plant, you will need a reasonable amount of moisture to transport it. That does not mean you cannot dry farm or that you have to have perfect irrigation. It just means that you need to do everything possible to ensure that the plants have access to water through the soil. Mulches help in many cases, but also adding things like compost and growing plants helps the soil to build water-holding capacity through the buildup of soil organic matter. Soil organic matter is incredible. It not only holds significant amounts of water, but significant amounts of nutrients your plants require as well. Generally speaking, the closer your soil organic matter percentage is to that arbitrary 8 to 10% mark, depending on your soil type, the less you need of other amendments. However, more important than just saying build soil organic matter is to say make sure your soil is set up to build and retain soil organic matter. And one of the key elements of that is indeed water management. I know a lot of agronomists will say that the type of water you use will have an effect, and I would listen to them, but in a pinch, just about any water is better than no water. You do not want to lose the microbial populations you've built by allowing the soil to dry out. Again, there are going to be regional considerations for all of this, so consulting with a local agronomist on your water is really critically important. It is as important as consulting with them on your soil because there may be salt issues, hard water, nitrates, or whatever situation unique to you it may be. There is such a thing as too much water. That is why testing your drainage is essential. To do so, simply dig a hole about 12 inches deep and about 8 to 10 inches wide at a slightly drier time of the growing season. Fill that hole with water and allow the water to drain. Once the water has drained, fill it again and see how long it takes for the water to leave again. The longer it takes, the worse your drainage is, and if it is still full or quite full after a day, you will need to address the drainage. It may be simply a matter of addressing your compaction to increase your drainage, or a more complicated matter of putting in drainage tile or picking a different garden spot. There is so much I could say on water, but this is already going long. So now, as promised, here is how I address soil amending. I do look at soil tests, but mostly I leave the chemical nature of the soil alone. I am not entirely sold on the idea of soil balancing and the base-cation saturation ratio methods, also referred to as the Albrecht method of soil balancing, but I do test the soils with labs that employ that methodology. I do not think the soil balancing approach, that is, adding rock minerals in specific ratios based on a specific type of soil test, is a bad approach per se. The research just does not fully suggest to me that it is entirely necessary. I have read the compelling arguments from experts like Solomon and others, but I am just not quite there yet personally, and there may be regions where it makes more sense than others. Feel free to disagree. I think the research is still developing, especially around how soil balancing relates to nutrient density. There are some good folks who do well with base-cation saturation ratio testing, and those labs are my go-to. I have also been getting more into the Haney test because this is a much more biologically driven soil test that measures what nutrients are available to microbes, as well as the soil respiration rates. Soil respiration is just important. That is how much CO2 your soil is giving off, and the more CO2 it is giving off, the more microbes are letting out, and the more CO2 your plants have access to put back into the system and turn into roots, leaves, fruit, microbes, and eventually you. Anyway, soil testing is a whole other monster to tackle, maybe at some other time. But for me, I look at the test and look for grave deficiencies and excesses in the soil. Only when there is something truly missing will I consider adding it. And I do try to cut down on adding to the excessive nutrients like phosphorus whenever I add something. It is hard to avoid entirely because we use so much compost, but it is good to be conscious of it. For nitrogen, I do prefer fertilizing composts like those derived from organic chicken manure, or I apply liquid fish emulsion sometimes to get the nitrogen cycle started in my soil. I apply them before heavy feeders or lightly around dense plantings of things like radishes. We use things like fish emulsions a lot in the tunnel around the tomatoes and cucumbers, but with compost, it is usually just once per year in the growing bed. With the fish emulsions, it is usually once per week depending on the growth of the plant and how it looks, and that usage will come down over time. Honestly, you should not have to do this nitrogen addition forever, or at least not that much, maybe with intensive crops like tomatoes and cucumbers, but less so with your field crops. You will hopefully, although all soils are different, be able to use less and less nitrogen amendments because as your soil microbial biomass rebounds and a static level of organic matter is achieved, your nitrogen needs can start to come more from the soil and from the air than an amendment because it is essentially already there in the soil. Of course, leguminous cover crops are also a great nitrogen source and source of organic matter when grown well and with the proper inoculant. One of the few microbial inoculants I believe is helpful. Don't dwell on that comment too much. I am not opposed to lab-grown microbes per se. I just believe the local microbiology is going to outlive and outperform most lab-grown biology, and I do not want to have to buy my biology every year. I want the soil and the plants to sustain it for me. Plus, I am a compost-making nerd, so for biology, I prefer well-made inoculating composts and worm castings, which I like adding to the soil mix to stimulate biology at the roots before the crop is even in the ground. I do use some biostimulants like humic acid and kelp, just adding a bit whenever I am applying compost or a compost slurry. Biostimulants and teas are such a big conversation that it requires a whole other video, but there is a lot out there on how to do those. For intensive crops like greenhouse tomatoes, I will, where needed, employ a foliar spray as well to keep up with deficiencies. I like foliar sprays because plants can very rapidly utilize them. There are several sites online that will give you indications of leaf deficiencies, and then you can purchase foliar amendments for those deficiencies. Always check 2 or 3 sites just to make sure you have got the right deficiency identified, preferably those with a .edu address. You can also do a SAP analysis, which is just sampling the tissue of your plant and seeing what nutrients are available to the plant in that moment and what it may be lacking. That will give you more precise information, and then you can consult with an agronomist on how to address that with sprays. Those tests can get expensive, but so can over-applying amendments or applying the wrong ones. Less is almost always more. By mistake, I have over-applied amendments in the past and literally been burned. Great amendments must be used correctly, so be careful and do your research. In fact, that last point is really important because if this sort of stuff still sounds daunting, that is because it is. It is a lot of work and research to understand plant nutrition and how to address soil health, and moreover, the science is still very much evolving. We understand strikingly little about plant nutrition and microbial interactions, but we know that water, compaction management, compost, and living roots lead to better and better soil health. Indeed, addressing those will solve most soil issues, and they are concepts that are much easier to wrap one's mind around. Then you can fine-tune your issues through amending and foliar feeding as necessary, because addressing the issues I highlighted here will make whatever you do add to your soil more effective. Okay, so that is the foundation. I wanted to do a little what to add when video, but the reality is that there are just too many variables, and this approach to me is way more helpful. But maybe more amendment videos in the future if you all enjoyed it, and feel free to add your insights as always in the comments section. There is an infinite amount to say on this subject. In fact, if you could add a 5th essential soil management practice, what would yours be? Because I know I could think of several others worth adding, but I will leave that to you because I have been talking forever. If this story changed the way you look at the life beneath your feet, please subscribe and like the video. We are digging deep into the secrets of the earth that have been overlooked for too long. Let's cultivate a better future together. The next treasure of knowledge will be revealed soon.